What an excellent day to kick off this Meet Qt Nordics webinar today. So the summer is now totally over and the darkness has fallen upon us once again for the next half a year here in the Nordic countries. And this is of course the moment we have all been waiting for. And my name is Janne Sjögren, and I'm the one of the two of the customer point of contacts here in the Nordic countries from Qt. And today we have 1 hour and 45 minutes to cover our agenda. So we have our product manager presenting the Qt framework and the roadmap. And then we have GE Healthcare presenting their solution on Qt. And then we have a live demo on how to create a graphical user interface from Photoshop on a low-cost MCU wearable device. And yeah, it's been now 25 years since the 1.0 version of Qt. At that time, we were still called Trolltech in Norway. And then Nokia 2008 acquired Trolltech to create the next generation operating system on their mobile phones. And then suddenly, in some point of time, a few years later, they jumped on Microsoft Windows, as we know, and the Qt technology ended up in the hands of Digia, who then a few years later separated the Qt technology as its own company called the Qt Company. So that was 2015, and then 1 year later, Qt Company listed on the stock exchange of Helsinki. We have personnel in 12 countries around the world. The Qt technology itself is pretty much all over the place. So we can see downloads even in North Korea, which is interesting. And I wish you all a pleasant webinar today. My contact details are shown there on the top right corner, Janne Sjögren, and my email and my phone number. And you can also ask questions in the Q&A section on this webinar. And yeah, I wish to meet you all one day. Alice.
So thank you so much, Janne, for the intro. And I would like to welcome everybody to our webinar. My name is Alice Håkansson-Toth, and I've been with the company for about like 6 years now. And I'm working together with Janne in the Nordics market from the commercial angle. So we support all the customers in Nordics together. Janne is based in Finland, I'm based in Oslo, but we work together on all these countries. You can see the contact details up in the right corner, like Janne said, so please mark it for yourself for later in case you would like to get in touch with us. So just to take over from Janne, when he mentioned Nokia, this is actually the old Nokia office where I'm typically sitting, of course not right now because of the COVID, but that's where I'm based. And as you can see from the slide as well, the Qt company works with leading companies in 70 plus, which I would say pretty much everything and everybody we are present in all industries, in automotive, or as I would rather define it, more like vehicles. So not only cars, but also e-bikes, and you're supporting customers for buses and other vehicles in general. We also work with customers from medical industry, as you will see also from the GE presentation later on today. We have maritime customers, wearables, and many customers from the automation industry, and more basically where they develop and deploy with Qt applications and UIs, and also connected device worldwide. Just to mention some of the success stories that we have in the Nordics countries, I think that's what I would like to start with. The list is long when it goes, you can find on our website. So I personally was working closely with GE Healthcare, Cisco, let's say Koenigsegg and Ulstein, who is now called Blue Control. But like I said, worldwide we can mention companies like LG, Bosch, Schneider Electric. So you can take a look at the customer success stories on our website if you wish later after the event. So what we are doing with Janna, there are customers facing different kind of challenges. Some would like to shorten their time to market and beat the competitors with the product introduced to the market faster. Some customers just would like to refresh their outdated UI or would like to lower their total cost of ownership. But we can also help with resources. So if you wanna, if you're lacking resources in development, we can help with that too. But also can speed up your development, basically just using the cross-platform ability of Qt. So you can develop, maintain one code base and deploy it for different operating systems. As you know, we are supporting different platforms. We have a wide range from desktop, mobile to embedded, but also RTOS and bare metal recently. So it's very scalable, and we support different machines from low-end, basically low-end MCUs to high-end machines. Just to close this section a little bit with the commercial part. So as you know, Qt is licensed in the dual licensing model. So we are available both open source and commercial licensed. So there is no vendor lock-in in our case. That our latest and recent product releases were coming out and being licensed under GPL and GPL version 3. So those are the rules and regulations that you have to comply with if you decide to go that way, which is really important to do so as well, just to make sure that you are compliant and you're not going to lose your distribution rights. There might be some questions later on, and also about like what kind of regulations are related to your specific project and whether open source or commercial is the right option for you, and also how we can help you with a commercial license. So we are open for those kind of questions, both during the presentation and also afterwards. So feel free either to call us or email us, either Janna or myself, and we're gonna help you going forward. As unfortunately, there is no dedicated time to discuss licensing. We would be happy to help you to choose the suitable licensing option for you. So thank you so much. I think I would like to pass the word to Santtu, who's gonna continue with our product intro and roadmap. Enjoy.
Oh, good morning, good afternoon, everybody. I'm Santtu. I'm based here in Qt in Espoo, in our headquarters, whereas currently I'm based in my downstairs cellar. And I'll be talking today about 30 minutes. I have a presentation on the designer and developer working flow, how we have been evolving and improving our products so that the time to market and total cost of ownership is lower for our customers. Then I'm talking shortly about the benefits of the cross-platform framework. I have a few slides on the roadmap. I'll be covering the next big thing is the Qt 6 in slightly more details, and then we should have about 10 minutes for the Q&A before we jump to the next presentation. So that's roughly going to be my agenda. And if you have questions during the presentation, use the Q&A button on your Zoom meeting and add your questions there, and we'll be answering them either during my presentation or at the end in the Q&A section. So first, going into the designer developer workflow. So a couple of years ago, we looked at our customer projects and where did our customers spend time and how their processes were working. So it became quite clear that pretty much all the software implementation projects have these specific phases or tasks, no matter how the organization is set up. So there are designers doing the visual designs, designing the look and feel of the buttons and the UI elements. Then there are interaction designers that are doing the interaction designs for how do you go from one screen to another, and how do you navigate within the application, and how does the user interact with the solution. And then there are developers who are implementing those designs. And sometimes this is one person, but in a bigger projects and organizations, they are different persons and using different tools. And when we looked at the custom projects, one of the root cause or the challenges that we were facing is that everybody was using a different set of tools. The bridges and the transitions from one tool to another were poor or didn't exist at all. At worst, the interaction designers were saving wireframes and writing long text and sending a PDF attachment to the developer, who was then doing some violence to the desired designs, and it did not turn out to be at all the way the designers wanted it to be. And then this went back and forth quite a long time. So that resulted in a lot of this kind of invisible waste and invisible work that did not really contribute to the final product, but was part of just the process of how things are being done. So we looked at this maybe 3 years ago, and then we came up with the ways to solve that, and we now have a full end-to-end solution in place. And so how do you do it with the Qt is that the designer is drawing the dials and the elements of the UI in their favorite tool, be that Photoshop or Sketch or something else. But then they can export those from those tools and import them into the Qt Design Studio, and they can finish the design in the Qt Design Studio of the UI in there, and they can add the interactions, animations, navigations into the tool. Behind the scenes, what happens is that the Qt Design Studio is actually is saving the UI and designs in the QML, in the Qt markup language format, which is actually the final UI description. So the UI definition that the designers are creating is actually the UI of the application. Then developer picks that into the project and adds the application logic and adds the integration to the embedded device, and then hands that over to the designers. And from that point onwards, the designers and the developers can work together. So if the designer does any changes on the UI, the developer can see it. If the developer has to do some changes, the designers can see it. And both parties, developers and designers, can actually see it live on the actual device as they go and do changes. So this is very important for designers because they can see what does it look like in the right size of the screen, with the right color depth, with the right aspect ratios, and with the right brightness and contrast and all those in the actual design. And they can also see that if they add let's say a 3D elements with 2 million polygons, that what is the impact into the performance without waiting for the developer to deploy and design that. So it brings a lot of benefits in time and how people operate together in this. After this is done, then there is the maintenance phase. So Qt 5 was released in 2012, and Qt 5.15 is going to be supported until 2023. So that's 11 years of binary compliance in the maintenance. And some of our customers, it's super important that they can support their products over long periods of time. And they don't need to worry about the framework changing or the tool changing, but they actually get up-to-date support without changing the application over a long time. So the maintenance is super important aspect for that, and we can really provide that as part of the framework. So with this example, we actually, even though it looks very simple, we removed a lot of waste from the product. So there has been no need to write separate UI specifications, because the UI specification that comes out of the tools is actually the UI of the solution. Prototyping and testing is very easy, very fast. The developer can do the first deployments into the embedded device in about 5 minutes, so it's really quick. The designs can be tested on real hardware, so that's a huge benefit for the designers, that they can see on the real hardware what is it that they are designing, that is it actually working on that right display. And there's a lot less of rework and frustration going back and forth between the different parties when using the end-to-end Qt design and developer tools. So that's the big thing on that side. Then there is another angle, which is about the cross development and addressing multiple different products by this same team. So we often have customers who are doing more than one product. And in this example, I have a customer doing a line of washing machines, where there's low-end washing machines using a microcontroller that has a smartphone-like user experience, may have some very basic animations, is using direct bare metal or FreeRTOS underneath. Then there is another product which is a higher end, has a 2.5 D graphics already, has a full Qt framework, may have some connectivities running on Linux, and has really nice animations. And then there may be a high-end product that may have one or more displays, that has a full 3D, has a full connectivity, is running on Linux and RTOS. And then there may be also a companion application running perhaps on a PC or on a mobile phone or even on a WebAssembly. And all of these applications are actually created by the one team, and it's actually using the same UI assets and the same graphical UI underneath. So it's very easy for the same team to do a variant of the same application for these different use cases, instead of having multiple different teams addressing these different targets, as it would be with something else than Qt. So that's another big benefit of the using the Qt. I'm going to jump to the sort of more details into the cross-platform framework and why does it matter? So the frameworks are opinionated in their style. So they are not like a constant collection of random libraries where you would need to take care of the compliancy elements between different libraries. When you get a framework, everything that comes with it works together. So it has the libraries for the backend, and Qt is much more than just the UI. Qt is actually having over 50 million lines of code and has a lot of backend connectivity, hardware adaptation, operating system adaptation that is hiding the underlying plumbing from you. It comes with the structure, it comes with the best practices, it comes with the samples, ready-made applications that you can reuse and get started fast. And it is dictating on how to do stuff, so you don't need to reinvent the best practices yourself, but you can benefit the best practices of the 1.5 million developers behind Qt. It comes with the toolbox, so you'll have the full set of tools for analyzing your application, optimizing performance, for deploying into different targets, for testing them in the different environments. So you'll have all the tools in one download and in one setup, instead of trying to harvest those from multiple different sources. And it makes it very easy to apply those best practices learned and known through the different industries. So the good framework is driving structure and consistency for you. When we look at the frameworks and the value of using Qt and the framework is that increases from top to bottom, from individual developer have their own benefits, and then the team has their own benefits, and then the whole organization has, of course, another set of benefits. And I'll be going through these three different angles. So For a developer, once you know one part of the Qt very well, it's very easy to understand the other part of the Qt. So it's created by developers for developers. It's very easy to learn and intuitive to learn. So once you know C++ and once you know the basics of the framework, understand if you know one part, you know it's easy to jump to the other part. You can use one set of skills for multiple different platforms. So you don't need to learn separately, you know, how do I do stuff in this operating system and in that hardware. It's a one set of skills you can utilize across different targets and environments. And the APIs are very consistent. So we have styles on the APIs. So the way you use the APIs and the way you use Qt is quite uniform, and it makes it easy for developers to use. The complete set of tools you get with it. So there very rarely is a tool that wouldn't exist. It is out there, and it's actually part of our offering. So if you need to tune Qt, you need to do some profiling, or you need to do some debugging. All that is integrated and part of the offering. So you don't need to find those from somewhere else. So we can think of it as like a Lego block. So there's a lot of Lego blocks out there. It's more like an imagination and how you utilize those as a developer. And you can really kickstart your project with the ready-made reference images on the Meet Qt, so that if you can take an industry standard the evaluation board out there, you can get it running in a matter of minutes. And then there is a huge community behind Qt. So there is a forums, discussion forums, emailing lists, and of course commercial support available for developers. So you never walk alone there in that. And I think, you know, if one of the developers I interviewed said that, you know, why he really likes Qt is that he can impress his boss. He seems smarter than what he thinks he is. When he uses Qt. So that was his argument why he liked it. Then if you look at it from a development team angle, so for the team, the framework brings this consistency, structure, and standardization. So for a team, it's very easy for developers to pick tasks from each other, to share work, from move from one project to another. It's also very easy for the team if they need to implement, let's say, a mobile phone and an embedded target and a desktop application, and then they need to add a button or they need to add a function into their solution. It's very easy for them to implement that in a consistent and a uniform way across different operating systems and targets, because they need to implement it once and then, you know, tune it to the platforms. So it's very easy for them to do that, and we offer a stable API, so they don't need to worry about that. What happens if there is an update in a half year, or is there going to be support for this library in a year from now on? They don't need to worry about that kind of things for the team level, because Qt has been proving very long maintenance and support periods for our platform. And then, of course, for the organization. All of this builds into the organization benefits for shorter time to market, lower total cost of ownership. You can outsource the underlying plumbing work to somebody else and focus on the things that are really matter for your solution, which is typically the UI and how do you differentiate from your competition. So these are the kind of things that really matter then, of course, for the organization. So that ends the framework part. So I will be moving into the roadmap, looking into the roadmap of Qt. So if you look at the blog and the Qt web pages, you may get a bit confused because there are so many releases and announcements of different releases, and every week we release something, so it may get confusing. But when you drill down to it, we have two kinds of releases. So we have time-boxed releases that come out twice a year. So there is a November and May releases coming out, and those time-boxed releases are the big framework, all in kind of release framework that are coming out. So the Qt 5.15, Qt 6.0, 6.1, they are schedule-driven time-boxed releases, but that also means that the schedule is the king. So the content is moving. So if you ask me that is so-and-so feature going to be in 6.0 or 6.1, maybe difficult to say because it's time-boxed. So we keep the schedule, but then the content is the moving part. But that's how it works with those releases, and that brings our customers predictability. And they know that there's going to be a new release in May and November. Then they can follow the individual features that are they going to land in that release or not. We also have feature and fix-driven releases. So we do have the bug fixes, security fixes, maybe updates to the underlying operating system adaptations if the operating systems are evolving, and those are for the framework there releases like the 5.15.1, 5.15.2, and so on, 6.0.1, 6.0.2, and those releases we do when we need to do a release. So if we find that there are critical issues or security bugs, or there is enough of important fixes that are going in there, we'll make a release. So those are driven by features and fixes. And then the tools, the two big tools, the Qt Creator for the developers and the Qt Design Studio for the designers, they are also feature-driven releases. So we do the features that are needed by the designers or the developers in the IDE or in their tooling side, and then we release those based on features. And how we then mix and match these is that when we do the framework releases, let's say Qt 6.0 later this year, we pick the latest Qt Creator that is out there and available, and we make that part of the framework. So that's how those two worlds then combine. So if you look at the timebox releases, the current roadmap is that the Qt 5.12 long-term support release, which is supported for 3 years from the release, is still going out there. It's getting bug fixes, and it's going to be supported towards the end of 2021. 5.14 that was released roughly a year ago is going to be end of life very soon. 5.15 is also on long-term support release. It's going to be released supported until May 2023, and we will be releasing Qt 6.0 in December this year, 6.1 in May next year, and then the 6.2 long-term support release in November next year. And the Qt 6.2 will be an LTS release, so that will be supported for 3 years until 2024. And then we do offer for our commercial customers also extended support. So if they are in a specific release of Qt and they need fixes for themselves, or they need us to support them in their environment, then of course that's a commercial offering and offered as a service, but those are case by case. This is the generic offering for our releases. So the Qt 6 is on the lips of everybody, so I'll be talking a few words about the highlights of the Qt 6 and the big things in Qt 6 in there. So when we look at the Qt 5, when we released Qt 5 in 2012, the OpenGL was pretty much the only backend graphics architecture out there that was a standard. Other environments did not have a standard graphic architecture. So the Qt 5 is actually built on top of the OpenGL graphics-wise. And then in the 5.12 and in the 5 series, we introduced later on the 3D. So the 3D content did not really exist in 2012, especially in the embedded, but it did not really exist at that time in such a manner as it is today. So the Qt 5 was really optimized for the 2D content, and then the 3D content in Qt 5 was added as a separate runtime from the 2D, and that made it a little bit complicated for creating this kind of a combined UIs that are integrating both 3D and 2D elements together in one UI. So in the Qt 5.15, the basic architecture of the Qt 5.15 is same as in the 5.12, but in the 5.15 there is an optional new scene graph which is combining the 2D and 3D into one architecture. That's based still on OpenGL, and that's optional. in the Qt 5.15, and that is going to be the core of the graphics architecture in the Qt 6. And in the Qt 6, it also is natively then integrated into the underlying architectures, be that OpenGL, Vulkan, Metal, or DirectX in the Microsoft Windows world. So that's the evolution of the scene graph architecture from 5 to 6. So if you look into the Qt 6, the big thing is, of course, the new graphics architecture. So that's the rendering hardware interface, support natively directly the different graphics backends, and that also allows us to, when we are isolating from the OpenGL, it also allows us to add other new, today unforeseen interfaces that may be coming in this front. We can of course support graphics with both with and without GPU. We are ready for the next 10 years. So we have moved to C++ 17. So Qt 5 is C++ 11 minimum compliant. So we moved into C++ 17. We are fully 64-bit supported, and Unicode is everywhere in terms of graphics and text. So Unicode is now fully supported in all the modules. We've been reshaping from top to bottom. So QtQuick 3D is now part of the 2D, the combined 2D and 3D engine. So the animations, state transitions, renderings, all QML language features are supported there. We'll have a full UI tooling support, so we no longer have separate tool for 3D and 2D content. There is a Qt Design Studio, which is one tool for all the content. And we have combined that with any QtQuick API. We've also done a lot of performance improvements on the type systems, on the property systems and property bindings and strong type QML. So we already know that we can beat the performance of Qt 5.15 with the Qt 6 on the graphics side. Couple of other big changes is the move to C++ 17, which is keeping up with the C++ standards. That means there is an improved code readability, there is a better performance, and easier to maintain, and it's of course better future-proof. We've also given up as QMake as our main build system. We have moved into CMake for our own build system, which is giving us benefits of on the industry-wide. QMake is still supported for the Qt-based projects, but if you are using a project that is using also some non-Qt elements in the project, then of course CMake is definitely your choice. For platforms, the support on the Qt 6 is pretty straightforward, the same as with the earlier versions. So we have the usual suspects on the host development environments. Of course, keeping up with the updates on those. So moving into the latest versions. For the target environment, the Qt 6.0 is more limited in terms of supported targets than the Qt 5.15. So we do have of course all the hosts, bus Windows, Mac, Linux, embedded Linuxes, and mobile phones there. But we'll be adding more or support into the embedded side and real-time operating systems in later releases on Qt. So Qt 6.1, 6.2 will have more target supported than 6.0, and the intent of that is that 6.2 is going to be on par or better than Qt 5.15 in terms of supporting different targets. So you can follow this. There is actually an avalanche of blog posts planned for the Qt 6. You can find them in our blog.qt.io with the tag Qt 6, and there's a lot of content in there coming up. So I think we planned like 50 or more different blog posts on different parts of the Qt 6, all the way from the nitty-gritty details to higher level benefits and others for different audiences in the blog. So that ends my monologue of 30 minutes in the quick run through from different aspects of Qt. So now it's time for questions and answers. So you have the Q&A button below. That's where you can type in your questions. And if the presentation was so thorough that there is no questions to ask, then of course we can cut it short and move to the next presenter. But I'll give you a minute to think. And at the end, we also have some time for Q&A, so you can let it boil and prepare a good question, and then we can cover those at the end. So we still have time at the end of the session for that too. Well, I have a question that is it easy to port applications from Qt 5 to Qt 6? It depends what you're using. So Qt 6.0 is a minimal subset of features that may not have support for all the features that are in the Qt 5, and we are gradually bumping that up in the Qt 6.1 and 6.2. It should be fairly easy. We are preparing some tools also to find items if there are issues there. And so we expect that you would not see such a hurdle as people were seeing when they were transitioning from Qt 3 to Qt 4, which was notorious for the transition, or from 4 to 5, which was not that bad, but still some people were quite upset with that. So we try to learn from those and make it easier for transition. Then there is another question. So when we are moving from QMake to CMake, is there any plans to support SCONS or other build systems? So SCONS. So I actually don't know that part. I think we are focusing on CMake, but that is something we would need to talk offline and cover separately. Unless Amit, you would have any details on that one.
No, I think we will take the question offline. Principal build system what Qt is having is the CMake, and if you want to compile all libraries with another build system, then you have to write those make files by yourself. But yeah, for this SCON, we need to check it.
Yeah. Yeah. Then there is a question. Is that how do you have numbers to substantiate the Qt 6 is beating Qt 5 on graphics claim? Yes, we will be releasing a blog post on that fairly soon. So I didn't have all the data to be able to show it here. So we are gathering that data and putting it together. So we should be able to release that fairly soon. And of course, there's going to be a series of Qt 6 focused webinars also in the future. So where we have a much longer and much better coverage on the Qt 6 than these couple of slides that I ran through today. So would welcome you to join those. Yeah, then there's a question about the marketplace, that given that there is now a marketplace, shall we expect less modules to be included in Qt 6 compared to Qt 5 and not covered by the standard commercial license, by rather to be purchased separately? So that actually has two different questions. So one question is about the marketplace and how we do release the Qt and the Qt framework. So we expect that some of the items, when they go out with the framework, actually never get updates with the framework, but they add to the payload of the framework. So those things we've been thinking that we should be maybe taking outside of the base framework and make them part of the marketplace offering, so that so that we wouldn't need to release those libraries separately every time we release the full framework. So that is about how do we roadmap and how do we release and how do we make things work together, offering us a mechanism for that. Then the other aspect is the commercial aspect there, which is then that would commercial developers who currently are getting on Qt 5 features not get those in the Qt 6, but need to pay separately those from marketplace? That is not the intent. So we are not intended to do that, but I don't know if there is any details or any individual libraries that would go into that path. That's something which is, of course, a moving target and under planning. But the one big benefit of the marketplace is that it allows us to offer libraries that are currently not available for open source developers as a commercial libraries for them. And the biggest benefit, I think, for the marketplace is that it creates a market square where not us can offer stuff, but developers who are adding value to Qt can offer their libraries to customers and find their customers who are then, of course, able to find those developers who have meaningful additional additions that they can offer. So it's really for the community and for the ecosystem, and secondly for us in that sense. Then there's a question on the flow between Qt Design Studio and Qt Creator one way only, or is it a two-way? So it's a two-way workflow. So the designers can create the designs, and then of course when the developer picks those up, if the developer does any changes, the designers can see them, and when the designers are doing any changes, the developers can see it. It of course depends on how the organization wants to set up the repositories and how they want to share the files. So if of course the designers are and the developers are only storing the source codes in their own hard drive, nobody can see anything. So it depends how you set that up. But it's a two-way communication tools and a workflow process. And then I think I answered all the questions, did I? Thanks for very good questions. Let's keep them cooking. If you have more questions, just chat them in and we'll answer them at the end of the session. So it would be a good time for me to hand to the next presenter. So I'll stop my presentation.
Okay, thank you. Then I guess I will continue. Yes, good morning, everyone. First, I would like to take the opportunity to thank Qt and Alice in particular for inviting us to this event. It's always fun to share new developments and our experiences with Qt. My name is Sten. I'm an engineering leader in the display and image analysis group at GE Healthcare, or GE Wingmed Ultrasound. I'm here today to share with you some of our experiences of using Qt in a rather large and complex legacy code base. Code base that is in the healthcare industry, meaning that it has strong reliability and security requirements. I will start off by pulling you briefly through a bit about our company. I think we have to do that. We'll then dig a bit into the technical details, at least a bit high level. And we will round off with some updates on the current status of our products and our usage of Qt. So let's jump to it. As for the previous presentation, we have the Q&A button. So I will not answer, of course, during the presentation, but we'll be glad to answer any questions after the talk. Okay, most of you have probably heard about General Electric or GE. It's a huge global company with a proud history. It began already in 1878. It was founded by Thomas Edison himself, you know, the guy with the light bulb. It's actually the only company from the original 1896 Dow Jones Index that is still listed. And we count more than 300,000 employees worldwide. We are present in more than 160 countries. So it's rather huge. So presenting GE would be wildly out of scope for this talk. So let's try to narrow down a bit. Our team is residing in the GE healthcare part. So this is one of the 8 primary businesses of GE and generates 19 billions of US dollar revenue yearly with a profit margin at 18%. Not sure if that's this year though, but we have more than 50,000 employees worldwide, and it's a rather R&D focused industry. We invest more than $1 billion US dollars in R&D every year. And our core strengths are biosciences, medical imaging, and information technologies. Our team resides, we're digging further down into the hierarchy. We are in what we call clinical care solutions, which includes ultrasound, which is my field of expertise. GE has evolved into being really a technology leader on ultrasound. Many of you know think of ultrasound as when you only look at babies. So that's typically if you have had children, you have seen the ultrasound image of the fetus, but it's way more than that. We are mostly occupied with the cardiovascular imaging, which means imaging of the heart and vessels. You also have the women's health part with the babies or fetuses. And we have the general imaging, which does, for instance, breast and kidneys, and more, general imaging. So I'm dealing with the heart on our team. So we are in a part called GE Wingweld Ultrasound. So this is our level. We are based in Horten, Norway, and we have satellite offices in Oslo and in Trondheim. We are also working closely with the team in Wuxi in China. So we are focusing on cardiovascular ultrasound and also a bit of primary care. I will not dig that much into the primary care part here, so we'll mainly focus on cardiovascular ultrasound. Just like a 30 seconds course in ultrasound, what do? We shoot ultrasonic sound waves into the body. We listen for the echoes and deploy pretty advanced signal processing to generate images and extract diagnostic information. We generate both 2D and 3D images, and we also measure blood flows using Doppler effects, which I guess you remember from your physics class. Our product range spans from large refrigerator size systems costing a lot of money into the smaller handheld ones that can slip in your pocket. GE Wingweld Ultrasound actually generates 220 million US dollar revenue, and we have 220 employees, where actually 50% are working in R&D. So it's R&D intensive. GE Wingweld Ultrasound has its roots from the University of Trondheim in the late 70s, which is now called NTNU. It was industrialized in Horten, a small town south of Oslo, southwest of Oslo, by local investors and acquired by GE in 1998. And I think if you look into the timeline of our products, we can see that it's evolved quite drastically over these 40 years. Starting with a pretty basic Doppler device without any screen, and evolving gradually into what we have today, a full-grown imaging system capable of doing even real-time 3D imaging. So when the bugs are piling up and nothing goes our way, it helps on the motivation to know that we are doing it for a good reason. Every single day, more than 300,000 patients are diagnosed with one of our scanners, the GE Wingweld scanners. That translates to almost half the population of Oslo every single day. Naturally, this means we also get a bunch of feature requests. And this talk from now on will be how do we respond to those? So we want to add new and exciting features, and what we would like to modernize what we have, modernize UI, modernize the look and feel. We want to do it with a shorter lead time. We have a quite broad range of products, and we want to run on all of them. At least for some of the tools, we want to have it on every product. So we need to run on multiple platforms. We would like to have the opportunity to do rapid prototyping. And we would like to do this without breaking anything. Without breaking anything is a pretty hairy goal for such a large code base, but nevertheless, we should at least break as little as possible. Our challenge is legacy code. This is a large code base. It has been developed over several decades using a Windows platform. We are regulated by the US Food and Drug Agency, FDA, as well as the European Medical Device Directive, imposing quite strict risk and reliability requirements for us, and which sort of makes sense. After all, we have a patient on the other end. The ever-returning question for us is how to make new developers efficient in writing new features for our system without messing up a lot. Just a fun fact, this image is actually one of our chief engineers, Kjell Kristoffersen, quite a few years back, but he's still one of our key R&D persons, so he's still working for us. This is an old image. This is where Qt comes into play. Our solution to the challenge is what we have called the App API. This is an API that was developed to enable decoupling of visualization and quantification tools from the underlying software platform. So thus developing new tools as apps instead of integrating it into our large code base directly. This means that less knowledge about GE legacy code is required, and the apps may run out of the box on several products or platforms. It has some other tempting properties. For risk and reliability, these apps can run in a separate process. This means that if a new tool crashes, it would normally not take down the system, which is a very beneficial property in terms of patient risk. The framework enables rapid prototyping because we can do sandboxing quite easily. The API itself, as you can see on the top, is a COM interface. Probably not the most popular technology in use, but nevertheless, it's very convenient for us. And to implement apps, we have used Qt, which is a modern and easy to use framework that I guess Santtu already pulled you through all the benefits, and I think we are leveraging quite a lot from those. I have to be honest, the API itself is decoupled from Qt, so there's not anything Qt in the API itself. So even if we promote use of Qt, the app can also be written using other UI frameworks, such as C# or Python. But anyways, let's jump into an example. This is an actual screenshot from our workstation software. It's called EchoPack. It's running a tool called Automated Function Imaging, which quantifies the contractility of the heart muscle. So here you can see that the AFI application is here an ActiveQt window, whereas the application runs in a separate process. You can see a snippet here from the task manager. It's called 2D AFI. And it communicates with the rest of the software, the Echoload, the MFC application. You can see another small snippet from the task manager here by App API. And by this, it can get access to things such as screen information, any touch screen information if you're on the scanner, hardware keys, ability to read and write measurements into our worksheets and make them eligible for export, other export options, and so on. So it's the result is that this AFI looks fully integrated, and the customer is not aware that he's actually using a small app that is not in a way the standard code base. Yes, and if we look at the windows, we are of course doing this quite easily. So the EcoPack EcoPack window will create a small child window, which it allocates for its ActiveQt window. And it's properly parented and it works as one would expect. Yeah, a small additional comment here. So this Vivid software, and the one that's running in our EcoLoader application, that's actually MFC and a bit of WPF. So you can see that now it's possible then to mix UI technologies quite efficiently, allowing for Qt use. ActiveQt is the enabling technology for us. I think it's not very worthwhile to go into a lot of technical details for such a talk. The documentation on the Qt web pages is splendid, so I recommend you to go and have a look there if you're interested. But the highlights here is that we make the Qt application a COM server by inheriting what is called the QX AX bindable. The host is then creating the app as an instance using regular COM calls, called create instance, and attaches this control to a window. So it's a little bit of plumbing, but it's not too frightening either, at least if you are a little bit into the COM world. So a few words about our development environment. We are actually, it's a bit embarrassed to say, but we are as Qt 5.13, so we are lagging a bit behind. We will probably upgrade to 5.15 quite soon. We are already using CMake. QMake didn't work out that well for us. We have quite extensive, we have used the sandboxing properties of App API and how that works with Qt to deploy quite extensive regression testing on our continuous integration servers. So we're able to catch regressions already at the pull request level or at the very latest as a nightly build failure. And of course, we're deploying warning checks and static code analysis and everything that you would expect from a modern software development environment. Our final binaries are deployed to the product mainline using NuGet. That's that works for us. It's also a bit mixed picture, but we are at least using NuGet for now. And we are using the Google test, slightly a little bit of Qt tests for our testing frameworks. So let's break up with a little video. This is our launch video for our recently Vivid Ultra Edition release. It's called Powered by AI, Elevated by You. Let's see if I can get this one to work. That's always a bit fiddly. Hopefully, even with the sound, I hope.
There doesn't seem to be sound, so you might have to reshare if you want the sound in with the voice.
Let's see. Okay. So this is the Vivid Ultra Edition release. Of course, showing you quite a lot of information that you probably didn't relate too much to, but this is where I want to highlight our use of Qt again. So this is the slogan is powered by AI and also elevated by you. We can see how the marketing guy is happily presenting 9 new features. How many of these do you think have Qt in them? 5. So for this year's release, we actually have 5 out of 9 new features powered by Qt. So I would say that's powered by AI and a little bit also by Qt. I think that's quite amazing. If we look into the last 3 years, we have actually released 12 new features, all based on Qt. Both 2D and 3D quantification apps, and as well as some visualization features. 12 brand new features released in 3 years. This is quite extraordinary, at least for us and our industry. And I think the framework presented here is at the core of this success. I think there was probably not the last time we see a new feature based on this framework. So any issues? I'm not working in Qt, so I have to, of course, have to present some of the drawbacks if there are any. Of course, we have stumbled across some bugs and improvement opportunities, and we have contributed more than 50 patches back to Qt, which actually is quite a good possibility or an opportunity also for us. It's been mostly on ActiveQt, but also on some of the other modules. We have experienced quite some regressions on upgrades, which has been a bit fiddly, disappointing, but I think that's also getting a bit better. Using our framework, it's been a bit fiddly to get the correct performance and making the completely integrated feel and look in terms of startup times and use of memory. But that could also be a bit leaning on us and how we have implemented both in the API and also how we implement Qt. So we are a bit slowly learning and improving, but we're looking forward to Qt 6 with the promised improvements to performance. We have also noted that Qt tends to get a bit invasive, which is it's a bit maybe a bit too easy to use. So if we're not careful, it will at least in the beginning it tended to leak into areas of our code where it shouldn't be. We don't want all our developers to have Qt licenses, even if Qt company probably would like that. So we will move to Qt 6 when we are able to, but we are one of the companies that are a bit blocked by ActiveQt not being on the 6.0. But they're looking forward to get it in at a later stage. Finally, I would like to round off with some words about third-party app support. The App API framework is not only strictly limited to in-house GE apps. We have launched third-party support, and we strongly encourage third parties to develop apps for our systems. And these apps will be listed in the GE Healthcare Marketplace. How can we do this? This is a healthcare system. This must be extremely risky. Yeah, I think we have a good possibility to deal with the third parties quite safely. We are able to do process segregation, as we're told. The app is running in a separate process. We have quite graceful handling of crashes and lockups on the app. We are also able to provide different trust levels to the app in order to limit file system access and make sure we satisfy any regulatory requirements. And we're also providing third parties a subset of our API. We don't want to share our IP with everyone. This is an example of sandboxing, a small test app. You can see it's called Qt Common 3D Test App. We can see that it runs within low integrity level, and thus it cannot write to our file system and cannot do modifications to the scanner or the underlying computer. Well, one thing we figured out, it's not a big deal for us, but we saw that low integrity processes cannot move the mouse cursor programmatically, which limits the UI a tiny bit. But I don't think it's a problem for most of the app developers. We even started a developer program to encourage third-party companies to contribute. So that also includes an SDK toolkit on GitHub, including a developer community and also several arranged hackathons. So if this is interesting to some of you, go ahead and visit our Edison Developer Program webpage and check in for the opportunities. Looking forward to see any contributions to our marketplace. By that, I think I spent my time and looking forward to look at the questions. If I can get back to the questions. Let's see. No open questions. This was also crystal clear.
Just a reminder that you can submit the question by clicking on the button either at the top or the bottom of your interface. So.
I got the first question. What kind of contributions do you expect to your new marketplace? Yeah, that's of course a bit up to the developers. We have of course requests for quantification features that are a bit, you may call it odd, not the regular type of quantification features that doesn't have a broad audience. So that will typically be one case where a third party can provide a quantification tool to quantify something that there is a request for it, but there is not enough requests, to put it that way. So it doesn't get priority with us, and that will be one thing. But there are really no limits. So it's a bit up to the imagination. What we would probably expect is to see spin-offs from research or something like that. That's my guess. But this is very new. We launched this third-party support only a few weeks back, so it's quite new. Yes, we got another question on the third party. How would you validate the reliability and quality of such third-party contributions? Yes, that's also a very good question. This means that a third party that is needs to have its own regulatory approval. So we are only providing the API, the interface to our systems, but the companies providing the third-party tools need to have their own regulatory clearance, which then will imply requirements to reliability and quality. The business model, I got another question here. What is the business model for a third-party revenue share and the liability between GE and app developers? That I think I'm not the correct person to ask. So, but please ping me and I can put you in contact with the right people.
Okay, I don't think we have any more questions. So thank you very much, Sten. And I think we'll move on to Amit's presentation. So Amit Nainawat, who is a pre-sales engineer here at Qt Company.
Yeah, good morning, everyone. So let me share my presentation now. So I hope that everyone can see my presentation. So I'm going to present you one of our product, which is called Qt for MCU. Well, you might have known that we have several different product offering, but in this talk, I will just present the Qt for MCU. If you don't know what is MCU, the MCUs are very tiny processor, basically the Cortex M-based processor. They have limited memory and limited CPU power. So here on this small processor, even on that, you can leverage the Qt. So this is the outline of my presentation. I will talk about what is Qt for MCU, how you can install Qt for MCU, what includes Qt for MCU, and most of my time I will spend on the demo side. Here in the demo, I will show you the designer developer workflow, which Santtu was talking during his presentation. The designer developer workflow can work on any kind of platform, on the desktop, on the embedded, and even on the MCU. Then we will try to develop a small demo and flash this demo directly on a target hardware. So just going before what is Qt for MCU. So we developed this product 3.5 years before. Since then, it is we are releasing new releases with very fast pace. But why we wanted to do something on the microcontroller ecosystem, because there was many challenges in this in this ecosystem. There was the existing product doesn't have much flexibility. There was no scalability. You cannot compile your application developed for one OEM hardware to another one. The graphics widgets were also limited in terms of the UX. So we wanted to address all this challenge, and that's why we started developing a new product, which is called Qt for MCU. So basically, we integrated Qt for MCU in our ecosystem. And what does that mean? That means that once you have developed your application in the Qt framework, basically, yeah, you can cross-compile it for the desktop, mobile, embedded processor, and even for the MCU. What we did is we kept our tooling same. That means the IDE, Qt Creator, the designer tool, Qt Design Studio, you use the same tooling even on the MCU side. So it has several benefits. It's a unified developer experience. It's a unify even the user experience because you will reuse the same code across many underlying platform. While the Qt framework, it already has many libraries for your widgets. So yeah, it's faster to develop with the Qt framework. So what is Qt for MCU? Basically, Qt for MCU is a graphical runtime which is running directly on the different hardware. So there is no OS here. This graphical runtime, it's running on the hardware layer, and on top of it, you can already leverage the power of the QML language. So the UI here on the MCU also developed on the Qt frontend language, which is called QML. And then your backend logic connection to your, I don't know, with IP stack, with your Bluetooth stack or input output, you can very easily do with the C++ integration. So QML and C++ is very nicely integrated. I will try to show you this integration during my demo. One more word. So if you don't want to run just one process on this underlying platform, you can leverage some RTOS like free RTOS, which will allow you to run maybe the graphics in one thread and your backend process in another thread. So free RTOS is already supported out of the box in the Qt for MCU solution. There is a difference between the Qt for device creation, which is running on the embedded system, so basically on the application processor, and the Qt for MCU, which is running on the very tiny processor like Cortex-M. So there is the difference is in the device creation, you have the Qt backend libraries running on the OS itself. And these backend libraries are handling, like, for example, TCP stack, Bluetooth stack, CAN buses, and you name it. So we have libraries for very large set of protocols. So those libraries are not available on the MCU, because on the MCU you can understand it's a limited hardware in terms of the memory, in terms of the CPU processing. So we don't want it to bring all those heavy libraries inside the Qt for MCU product. We made it light, and if you want to integrate a backend library, you have the C++ code which you will bring in your project, and it will be integrated directly for the Qt for MCU project. Apart from that, the another difference which you can see here, it is the QtQuick. This is the library. On top of that, the QML language is built. But in this side, you can see it's QtQuick Ultralight. That means not all QML functionalities available on the MCU side. This is also done on a purpose as same as before. It has MCU has the limited memory and CPU, so we don't want it to bring all those QML functionality inside the MCU ecosystem. Qt Ultralight is just a subset of the QtQuick. That means if you have the Qt for MCU project already built, you can take this project and compile it for the device creation. So going up is not a problem at all. Yeah, so there is these two major difference. Apart from that, yeah, as I said before, the tooling between device creation and the MCU remains the same. You will use the same tooling across all our product offering. So how to download the Qt for MCU? So here also we kept the offering similar to our existing offering. So you have a from the Qt Online installer, if you have used it for the device creation or for the desktop. The Qt for MCU is a new tab in it, and you just need to select which MCU you want to work with. It will download the cross compilation toolchain, the tools to flush the binary application to the MCU, and tool to debug also. So we integrated the Qt for MCU solution unifiedly inside the Qt installer also. So you just have to use the Qt installer as you were maybe doing before for the desktop or embedded system. What it includes, once you have downloaded the package. So as you know, our DNA lies in providing lot of tutorials and examples. So we follow that DNA. So it includes several tutorials. It includes the examples with the source code. I will show one of those examples during my demonstration. Then it has the platform adaptation layer. So you may understand that the underlying hardware difference is also changing when you are using maybe ST or NXP MCU. So for adapting between different hardware, each time when you download a Qt package, you will also download the adaptation package for example, for the NXP, for ST, for the Cypress. So it has the platform adaptation. That means the framework is ready to use directly on your target platform. Then you have the QML libraries, so ready to use widget to develop your application. You have the design and development tool like Qt Creator and Qt Design Studio is already integrated with this package. Then you have this runtime graphical library. You may call it like a driver running on the MCU, but as there is no OS on the MCU, that's why it's just a runtime. Idea is the same, so it's a rendering engine which we built for you so that your UI can run directly on this graphical runtime. It will not you who will spend time how to render your application. So this work is already done by us. Then of course this is the another DNA of the Qt company. So we provide the support on the Qt for MCU. If you have special requirement, for example, if some MCU is not supported currently with this solution, you may ask us, and we will support you to bring those MCU in the Qt ecosystem. Going further, so what it includes, Qt for MCU solution. So it includes the rich library. So as we are already known on the graphical side, we brought all those richness of the graphical controls inside the Qt for MCU solution also. You can reuse the Qt for MCU solution. For example, if you develop on the Cortex M, your project, you can reuse the same component if you are using, if you are going higher in the CPU side. So same graphical asset can be used on the embedded side and even on the mobile if you want to develop your mobile apps. Qt for MCU also boosted by the QML. So the front end is language where you will write your QML code for the graphical user interface is the same like application development on the desktop on the embedded side. QML is based on the ECMAScript, so you can see it looks like JavaScript because JavaScript is also based on the ECMAScript, so very easy to learn. Then it's boosted by our development tools. We reuse the same development tool even on the MCU side. Lately, we have already integrated a font engine. So when we are talking about a small size of firmware binaries, the font can be a problem because if you want to develop an application going in the different sector of the word, the language integration can be complex. So each time when you integrate a new language, it increases the size of the binary. But now we have integrated a dynamic font engine based on the monotype Spark. And this allows you to have only one binary, which is suitable for all your different market. And this dynamic font engine, you can see that it also requires very less memory because the font engine is dynamic instead of having the constant here, where you integrate the glyphs of each font. Here the glyphs will be calculated on the runtime. That's why you have the less footprint of your binary. So that allows you to combine several applications inside one. That also allows you to target different market segment when it comes to the font and languages. Of course, as Santtu said, there are more than 1.5 million developers in Qt ecosystem. So you will also benefit from the community sources. So yeah, in the starting, I have presented you some challenges. So we try to answer those. Now you have Qt Design Studio, which is what you see, what you get editor. You can write and design your UI directly inside this editor. We will see it in my demo. The UI is scalable, so the size of the screen can be adapted as per your requirement. So no need to redesign the UI because just you have changed the size of the screen. It's cross-platform architecture, so the same project can be cross-compiled. Yeah, it requires some changes, but the same project can be compiled for the various underlying platform. You will benefit from a very large ecosystem of the Qt. And then we are a European company, so we have the offices in almost all countries in Europe. I'm based in France, so you have the local support almost all countries in France, and then in the another area of the world. Then the Qt for MCU solution, it comes with the large set of the QtQuick controls, which will enable you to design UI very, very fast. So it's you have the components which will allow you to build UI like a smartphone. So now it's time for the demo. Let me start my demo. So I will try to demonstrate the designer developer workflow. Well, you may know that most of the time we show designer developer workflow on the embedded side, but today I will show you that the same tooling can be reused. Same designer developer workflow can be also suitable for the MCU side. So this workflow is called design and developer because here is Qt creator. So it's designer developer workflow. So Qt has developed the plugin for the Adobe Sketch, and by this plugins, you can import artwork from Adobe and Sketch inside the Qt Design Studio. And during this process, Design Studio generates the QML directly for you. And later, this auto-generated QML code, you can add some UX in it. And the graphical part is validated by the designer itself. You can see the graphical part inside the Qt Design Studio. Later, project is passed to the Qt Creator, where developer adds the backend logic. So once visual design is validated by the UX engineer, and the code is passed to the developer uses the Qt Creator, where they work on the backend connection, add the C++ logic. So this tool is suitable for the software development lifecycle, where you design, you develop, you debug, you optimize, and finally deploy your application on the target hardware, like desktop or MPU, or even on the embedded target. In today's demo, I will import a smartwatch artwork from the Photoshop by using the Qt Bridge. Imported artwork will be used in Qt Design Studio to auto-generate the QML code by the Qt Design Studio. And in the Design Studio, I'm going to add a swept view between these two screens. I will also animate one of the needle. And later project will be passed to the Qt Creator, where developer can add the C++ backend logic, and to compile and deploy the application on the desktop and even on a MCU. So I will use HTML for MCU for my demo. So let me open the Photoshop bridge. So this is the Photoshop. If you know a bit about the Photoshop, artworks are divided into the layer. On the left-hand side, you can see the layer view. On the right-hand side, you can see the Qt Bridge. In the Qt Bridge, you have to set up how you want to export each layer of your artwork. You can export as a component. It creates its own QML file, a reusable component. You can export it as a child. It's a child to a QML object. You can merge it, the image layer, to create one single PNG file. Or if you don't want to import, you can skip the layers. So once all those properties are set and path is also set, you can just export it. So it takes some time. Meanwhile, I will show you the Qt Design Studio. So this is the Qt Design Studio. a tool for designer and UX engineer. Here you can design the UI, add the UX in your graphical application. So let's create a new project for the Qt for MCU. Let's call it watch.ds. I'm going to put in my old directory. You can select the screen resolution, but I will adjust it later. So it creates an empty project. So first thing first, let's import the artwork we just exported. So click on the button export. I'm looking for a metadata file and which contains all information about the QML, and I can just import here. And while it is doing importing, basically it's creating the QML file. It takes some time because it has to parse the all layers and create the QML file. You can see that QML files are written. So I can close the project. So you can see that the assets are imported. So first thing first, let's try to resize my QML. I already know my MCU has 390 by 390 screen size. Okay. And then also I'm going to change the color of the rectangular to black. Otherwise, between two different watch face swipe, you will see the white background. So let's do it to black. Okay. Now I have to adjust my project QML file called watch.ds to my screen size. So here also I will set 390 by 390. So now I go to my screen one QML component. And in my screen one QML component, I add the library QtQuick control because this library has the swap view. Remember, I wanted to add the swap view between two watch faces. And now I drag the swap view. Yeah, it's here. So I drag my swap view to my QML. And I have to adjust the swap view side so I can use this layout. I bind it to the parent, which is filling the whole parent. So swap view is now filling the whole parent. And now I can add my watch faces. So I just need to drag and drop here. So main watch face and the watch face running. So that's it. So my first UX is created. I save and I run it. So my swap view is already running. So second thing, what I wanted to do is the animate one of the needle. So I go to my watch face main. I go to my hour hand component. Let's animate the hour hand. So to animate, I need to add a timeline. This timeline will have 1000 frame. This timeline will animate the hour hand image. So I select the hour hand image and I go to advanced property. I select the rotation origin to the bottom. Yeah. And then I on the 0th frame, I can insert a keyframe. So I insert a keyframe like this. Then I go to the 1000 frame of my animation and it will be a complete rotation. I add another keyframe 360. So a complete rotation. I add another keyframe here. So now if I move in my timeline, you can see my needle is already rotating. So very easy to create UX. Now I have to expose this timeline current frame property to external uses, because that's how you will do the binding with the backend. And for adding a new property, you just click on this plus, and let's call it our hand timeline current frame property. It will be a integer. And the value is 0. So it's opened here. Okay, so a property with value 0. You can go inside the text view, and I need to bind the current frame. So you can use the set binding property of the current frame. And I need to bind it with the our hand item is called our hand, and my property is called our hand current time frame. So this is how you do the binding with one UI element with another. So my binding is done. And with this nice breadcrumb, you can go back to your initial component. And now if I open my our hand QML here, you can see that the newly created properties here. So for animating this our hand, this time I need to add another timeline. So same, so click on the plus, add another timeline. But this time I'm going to add a timeline animation for a very big duration. It will be a continuous animation. So I don't want to stop in between. Okay, some demo effect. Let me check. So now on my 0th frame of the timeline, I add the value of this property to 0. So same thing like before. So I add a keyframe here. And then on the 1000th frame, I add another property, which is 1000. So I add another keyframe here. If you want to check your keyframes, you can, you can check like this. So there are 2 keyframes inserted. And now I can just run this whole project. So I haven't saved it. So I have to redo it again. So if I run it, you can see our hand is moving. So our second UX is already designed. So app view is working fine. So now let's take this project inside the Qt Creator. Just a few words about the Qt Creator and Qt for MCU. You can see that there are already some demo projects available. I have already this watch demo project on my L4 MCU. And you can see it's working really very smoothly. But let's go back to our project. So I will open the same project again inside the Qt Creator, which is the tool for the designer. So this time I'm going to open CMake list, which is already created automatically. So CMake is being opened. So if I go in my CMake file, so I need to copy few lines and few dummy codes. So first of all, I'm going to copy the fonts and few C++ files in my project. I will show you why I'm copying those C++ file later. So I paste directly in my project. Now, as I already copied the font file, so I am adding those font in my project. So the first line is telling where to find the fonts. And second line is telling which font family is the default font family for my project. And now I'm adding all my PNG asset to my C++ project. So all files in the asset directory will be added to my project, and then I'm going to compile them with my watch.ts project. And finally, I have to add my all QMLs, which was auto-generated in my project. So I'm collecting all QML files and then adding those QMLs to my project. I don't need this anymore. I remove it. So my CMake is done. So I can select a kit and I compile my project first for the desktop. So the project is being parsed. Now it is being compiled for the desktop. So we will run it on the Windows. So the project is now running on the Windows. So this time it's a binary application. So you can even validate here your UI and UX. Now I can cross compile the same project for the HTML4 MCU. So I select the kit. I need to select it like this. So you can cross compile across various kit your project. So it's now being compiled. So I will show you my HTML4 MCU. So it's being compiled. Yeah, it's now linking. So now project is being returned to the MCU. You can see the LED is blinking. That means Qt Creator is writing the binary to the MCU. You can also see the download process here in the bottom. So project is downloaded, from binary is flushed. So you can see now you have the same UX which we designed. My swap is working fine. My needle is moving as we designed. Now going further, also to summarize, you can also add your C++ project into the project. That's what you will do normally when you want to integrate your C++ backend. So QML target generate interface, take a .h file as input, and then it generates a QML interface for you. I will show you this file later. And then if you have C++, yeah, if I'm taking all binary and the source file inside the project. And I have to tell my project which all C++ and .h file I'm going to compile. So I'm compiling let.h, let.cpp, and wrapper.h. So those files are already here, already integrated with the project. So if I go inside the wrapper, you can see this is the interface which you can use directly inside the QML. So LED dot set enable can directly called inside a QML project. So any of these QML can call that C++ method. So let's try to compile it. So now maybe, yeah, here you can see that the the let.cpp is compiled with my project, and now I'm able to call let.setEnable everywhere in my project. So this is how you write the C++ integration. So, but yes, this was just a quick demonstration how to integrate with the C++ interface. So, this is what I wanted to show you, the designer developer workflow, which is same for the it is same for the MCU, and it is same for the embedded and the desktop. So you can leverage your skills, your Qt skills on the MCU also. So let me see if there are some questions. Yeah, there is first question. Was CMake list.txt created by the QTS? Yes, so it's a very good question. So yes, it was the case. Though, so the CMake list.txt is also created when you create a project inside the Qt Design Studio. And why it is so? Because it will avoid you to create this CMake list file. And just because it is automatically created, you can open your Design Studio project directly inside the Qt Creator. So the same code base, same QML files, same assets will be will be shared between designer and developer. Both can work in the same environment. Yeah, I can. Let me see if there is some another question. Can you show the content of let.h? Is the wrapper automatically generated? So let me, let me reshare it. So yes, so this is my Qt creator. So let.h has two interface: green LED switch on and green LED switch off. And let.wrapper, this is the interface. It is calling these two functions. So actually, this is the main interface with the hardware. And yeah, well, this is just a dummy function, but those let.h will be then come integrated with your hardware. So in the let.cpp here you will write the interface with your hardware. So and another question is wrapper generated automatically? Yes. So this line actually, QUL target generate interface, it takes a .h file as the input, and it generates the interface automatically for you. So as I said before, so led.setEnable, you can call something like this, led.setEnable directly inside a QML. So this is how you do the C++ and the QML interface. So yes, the interface is generated automatically. So if there are any other questions, I just wait for a few more minutes. So if there are no more questions, I give back to our organizer.
Great. Thank you, Amit, and thank you everyone for your sessions today. We still have a little bit of time. We'll hang around a little bit if you have any questions regarding any of the sessions today. But if not, I'd like to thank you for attending and thank you to all our speakers today. So yeah, we'll hang around for a few more minutes to see if there's any more questions that come in. I think there was one that just came in now. I think that might be for Amit.
Yeah, I was speaking muted, so I have another slide. Let me show you that. Okay. So I don't have the footprint on the demo project which I have done. So this slide shows you the footprint of the example which is available inside the Qt creator. So this is also a watch, yeah, it's also a watch demo. And you can see that it was also run on the L4 MCU. And if you see the KPIs in terms of the frame rate, so we can leverage 24 frame per second, which is the minimum. Of course, it goes higher, like 60 frame per second. So it depends if you have many image rotation. So image rotation is very heavy on the PXP line. So it depends on what kind of animation you are doing. So you are looking in somewhere in between around 60 to 24 frame per second for the frame rates. And then when it comes to the RAM and ROM uses, so it depends on your application again. So if you have many images, well, this application has few images. So this one, the Qt framework cannot control. It depends on your images size. But the application itself is very tiny in terms of the memory requirements. So the QML libraries for the widgets and the C++ interface which is generated, everything is around, yeah, for this example is 300 kilobytes. Then in terms of the RAM uses, this is the memory which you will use when you will run the application. So this also depends how you are configuring your application. So this particular example is using the single buffering. So if you want to leverage very high frame rate, maybe you have to use the double buffering. So the frame buffer is around 360 kilobytes. And the runtime environment, the runtime on which the whole application is being rendered, of course, this is controlled by this is part which is coming by the Qt for MCU itself. So we are talking about less than 120 kilobytes. We are improving it enormously. These KPIs are taken on the Qt 1.3 release. I already know that on the 1.4 releases, the Qt runtime is less than 100 kilobytes. So we are talking about for this application, we are talking about somewhere about 2 megabytes of the flash uses, and somewhere around less than 500 kilobytes of the RAM uses. Okay, so there is another very, very good question. So are the image compressed or uncompressed? So when we designed the Qt for MCU solution, so images was one of the big concern, because you may understand that the Qt for MCU solution cannot have a PNG library to decompress and compress the images on the runtime. So what we did is, when you compile the project, the assets will create a array, and this array will include directly inside the Qt for MCU project. So instead of having a uncompressed image, you have again, instead of having a compressed image which requires a library to decompress and then display, we put this image in a byte array and then this image is not compressed. So this is one way we went forward. But then we realized the uncompressed images has a very, very large footprint. So there are techniques. So when you include an image now, it's always inside a byte array. But then on top of this byte array, you can put some compression mechanisms. So you can, some of your images are in the compressed format. Of course, when you say those images are in compressed format, it will take a little bit more time to display them. So use it really carefully. And then some part of your image can be uncompressed. So you can have the mix of both of them. So yeah, images can be compressed or images can be non-compressed in the Qt for MCU solution. So if you are looking for memory optimization, maybe you have to use the compressed image. And if you are looking for the very high frame per second, then in that case, you have to use the uncompressed image. But then if you want to have the mix between the speed and between the performance, you can choose on the each image, you can choose whether you want to put it compressed or whether you want to put it uncompressed. So yeah, the mix of compression and uncompression is available already in the Qt for MCU project.
Great, thank you so much, Amit. I think we have run out of time. So again, I'd like to thank everyone for joining. If you do have any more questions that you'd like to ask us, you can either contact Alice or Janne in the emails that we're giving in the beginning, or contact us directly at info@qt.io, and we can answer those questions. But I'd like to thank for everyone for joining, and have a great week.